Alrighty, one thing that many of you who had the class last year know, and that the newbies don't, is how to use L'Hopital's rule. And this is specifically for limits, so I wanted to make sure I got this in here, so that way it's not a new topic next week. Okay, so we use L'Hopital's rule for limits, and we use it when we get these indeterminate forms. In other words, we have a limit going to either infinity or to some number. When we plug in the number or infinity, we get something like 0 over 0 or infinity over infinity. You can plug in positive, negative infinity and get infinity over infinity. So when we get these two forms, then they're called indeterminate forms, and that's the only time you can use the rule of L'Hopital. Alright, and L'Hopital's rule simply says that if you plug in a function, you get one of these two forms. Then take the derivative of the numerator and the denominator and plug the number in again and see what happens. And if you still get one of those forms, do it again and again and again until you can't do it anymore to see what happens. So here's a bunch of examples. The limit as x approaches the sine of x over x. Well, if I plug my 0 in, I get sine of 0 over 0. The sine of 0, 0, divided by 0, bad, right? I have an indeterminate form. So I'm going to rewrite this limit. I'm going to take the derivative of the top, which is the cosine of x. Derivative of the bottom is 1. I'm going to plug my 0 in and see what happens. Well, the cosine of 0 is 1 over 1 is 1. So the limit for the sine of x over x is equal to 1. Another example, the limit as x approaches 0 of 1 minus cosine of x over x. Now look, x can approach other numbers besides 0. These are just a couple of examples I found in the book real quick, so I wrote them down. Okay, if I plug my 0 in, I get 1 minus the cosine of 0 over 0, and that the cosine of 0 is 1, so 1 minus 1 over 0 gives us an indeterminate form. Can't use it. So now when I take the limit, I'm going to take the derivative of the top, so it's negative cosine of x, and the derivative of the cosine of x is the negative sine of x, so negative times a negative makes that a positive. Derivative of the bottom is 1. If I plug the 0 in, I get sine of 0 over 1, which is 0. That's fine, the limit 0. Here's a few examples of repeated use of L'Hopital's rule. Here, the limit as x approaches 1. If I plug in the 1, well, I'm going to have 0 over 0. So I went ahead and took the derivative of the top and the bottom, plugged my 1 in, still got 0 over 0. That means I can repeat it. Took the derivative of the top again, got 6x over the bottom, plugged in my 1, and now I see that the limit as x approaches 1 of this function is equal to negative 6. Another one, using infinity. So if I plug infinity in, I get infinity over infinity. That's bad. Derivative of the top and the bottom, I get this. Plug infinity in, I still get that indeterminate form. So I take the derivative of the top and the bottom again, take the limit, and it turns out to be 2/3. And that's limits. Excuse me. Excuse me. Oh my goodness. I'm sorry. That's limits using L'Hopital's rule. Fiend.